Hello, everyone, and thank you for joining me on this channel, Adults ESL Online Learning. I'm Dr. Hernandez Smith. In this video, we are going to discuss Section 6, Electronic Communication from Module 2. Table of Contents, Section 6, Electronic Communication. Objectives. Vocabulary. What is electronic communication? Transmission channels, sending and receiving signals, how the telephone works, how radio works, how television works, advances in electronic communication. Objectives. Identify and describe 4 types of transmission channels. Explain how signals are transmitted and received. Describe how telephones, radios, and televisions operate. Explain and give examples of radio frequency identification systems. Vocabulary. Number 1, electromagnetic wave. Number 2, telecommunication. Number 3, amplitude. Number 4, frequency. 5, transmitter. Number 6, receiver. Number 7, modulation. Number 8, satellite. Number 9, charge coupled device, CCD. What is electronic communication? Electronic communication systems involve the transmission of information using electricity. Most modern systems use invisible electromagnetic waves that travel through the atmosphere. Some electronic communication systems are used for telecommunication, which is communication over a long distance. Transmission channels. Transmission channels are the paths over which messages must travel to get from the sender to the receiver. They are like highways for moving information. Information may travel over wires, cable, or optical fibers. Many devices, however, use microwaves or radio waves as a transmission channel. Copper wire. Local telephone messages often travel over twisted pair wire. This consists of 2 thin insulated copper wires twisted around each other. Coaxial cable. Coaxial cable usually consists of 4 layers. A central conducting wire is surrounded by an insulator. Then there is another conducting layer, which is surrounded by a final insulating layer. Most cable television signals are transmitted by a coaxial cable. Optical fibers. Optical fibers, also called optical fibers, also called fiber optics, are being used increasingly to carry telephone, television, and computer data. Optical fibers are thin, flexible fibers of pure glass that carry signals in the form of pulses of light. Optical fibers have many advantages over copper wire or coaxial cable. Electromagnetic waves. The electromagnetic waves used by communication devices are the result of electromagnetic radiation. All wave forms have both amplitude and frequency. Amplitude refers to the strength of the wave that can be seen in its height. Frequency is the number of waves that pass through a given point in 1 second. Frequency is commonly described in units called hertz. Sending and receiving signals. In order to send and receive signals, information must be in a form that will work with the chosen transmission system. Transmitters and receivers. Transmitters are devices that change signals into sine waves and send them out carried on radio waves or microwaves. Receivers collect the waves and decode the signals. The sine waves are superimposed on electromagnetic carrier waves using modulation. When the frequency is modulated, the waves are spread farther apart or crowded closer together. This type of signal is received on FM, frequency modulation radios, and cellular phones. Sometimes the amplitude of the carrier wave is modulated. This type of signal can be received only by AM, amplitude modulation radio. In the transmitter, the modulation signal is amplified and sent to an antenna for transmission. These receivers detect the signals, boost them to the usable strength, and convert them into the voice, sounds, or data originally encoded at the transmitter. Satellites. A satellite is a device placed into orbit above the Earth to receive messages from one location and transmit them to another. The satellite serves as a transmitter and a receiver. A satellite contains many transponders. Satellites make it possible to communicate instantly. Live broadcasts depend on satellites to transmit messages about events as they are happening. How the telephone works. The three most common electronic communication technologies are the telephone, radio, and television. The telephone is based on the principle that sound waves cause vibrations that can be encoded into signals. The telephone includes a transmitter located in the mouthpiece and a receiver located in the earpiece. Electronic telephones. Modern telephones are mostly digital electronic devices. Integrated ICs have replaced many of the parts in older telephones, such as the bulky wire coils. Cellular telephones. The most significant development in the telephone technology in the past few decades has been wireless communication with lightweight cellular telephones. These devices use radio waves to These devices use radio waves to transmit conversations, thereby omitting the need for connecting wires and cables. Today, most cellular calls use digital technology. As discussed it converts the voice into a computer language before transmitting it via radio waves. Digital technology makes it easy to encrypt electronic signals so that no one can listen in the conversations. Oh no. Digital cellular technology makes available new options called personal communication services. They include messaging and many other services linked to your cell phone. Getting a message to the right place. How radio works. Radio is a form of mass communication. Like other forms of electronic communication, a radio system uses signals. Each radio station and device that works on radio waves, such as CB radios, military radios, and pagers, is assigned a certain frequency. When you set your dial at a number, you are tuning in the frequency of a particular station. Satellite radio. With satellite radio, also called digital audio radio service, you can listen to a specific station as you move from one location to another. This is made possible because the digital signals are transmitted via satellites and radio receivers on the ground. How television works. Television is an electronic system of transmitting pictures and sounds over a wire or through the air. The television camera. A television camera is most often referred to as a camcorder. Camcorders record audio and video information separately. A microphone is used for sound while images and light are converted into electrical signals using a charge-coupled device, CCD. The CCD is a tiny panel having about 500,000 light-sensitive cells called photosites or photodiodes. Transmission. Broadcast television signals, audio and video are first sent to an antenna. The signals are amplified and modulated before they are transmitted via antenna, satellite, or cable. This process is very similar to the way radio signals are sent. However, television signals higher frequencies. The television receiver. The television screen is the flat part of the CRT, cathode ray tube. In a color television, the surface of the CRT is covered by groups of green, red, and blue phosphors. Phosphor is a substance that emits light when given energy. Digital television. New guidelines from the Federal Communications Commission are requiring eventual adoption of digital technologies. This brings significant changes in television broadcasting. High-definition television. High-definition television, HDTV, is a special class of DTV. This brings significant change in television broadcasting. During the transition phase from analog to digital, analog transmission television sets will still function. When the changeover is complete and analog transmission is discontinued altogether, digital television set, DTV, will be required in order to receive television broadcasts. Advances in electronic communication. Some engineers are designing innovative ways to apply electronic communication technologies to new products and systems. RFID technology, radio frequency identification. RFID technology is a wireless system that can be used to track goods or vehicles. RFID technology has many benefits. However, some people are concerned about how access to personal information will affect privacy. Reducing EMI. Human factors engineers must design products and systems so that people will not be harmed by radiation. Electromagnetic radiation can also cause unwanted electromagnetic interference, EMI, that can disrupt how other electronic devices work. Okay, let's review Section 6 Electronic Communication Quiz. Enter in your email. Section 2 of 2. Main ideas. Electronic communication systems involve the transmission of information using electricity. Transmission channels are the paths over which messages must travel to get from sender to receiver. The three most common electric communication technologies are the telephone, radio, and television. Advances in electronic communication include RFID tags and technologies used to reduce electromagnetic interference. Number 1, name the 4 types of transmission channels: copper wire, coaxial cable, optical fibers, and electromagnetic waves. Number 2, how are signals transmitted and received? In order to send and receive signals, information must be in a form that will work with the chosen transmission system. Number 3, what principle does a telephone use? The telephone is based on the principle that sound waves cause vibrations that can be encoded into signals. The telephone includes a transmitter located in the mouthpiece and the receiver located in the earpiece. Number 4, how is frequency used in radio and television? Broadcast television signals are first sent to an antenna. The signals are amplified and modulated before they are transmitted via antenna, satellite, or cable. This process is similar to the way radio signals are sent. However, television signals use higher frequencies. Number 5, what is an RFID? Radio frequency identification technology is a wireless system that can be used to track goods or vehicles. Number 6, how have cell phones changed social interaction? People send and receive text messages and can FaceTime their calls. Thank you very much for joining me, and I hope this video was helpful. I appreciate all of your support. Thank you so much, and I'll see you in the next video. Bye-bye.